Hello, in this video we'll do some review through section 6, solving systems of equations using the graphing technique. So, just before you pause, one quick thing to realize, there was one more problem I wanted to do in this section 5 review, so let's just do that here. Let's find the equation of the horizontal line that goes through this point. This is where we just got to remember our facts, folks. What's so special about a horizontal line? Hopefully by now, we just know it's a y equals line. Whatever the y is here, that's the equation of the line that goes through it. That's it. You could, again, this is the nice one, that a horizontal line, we could remember, oh, m equals 0. We could then go through the whole, there's my point, there's my slope, y minus the y equals m times x minus the x. Definitely still correct. But over here, multiplying by 0 is just 0. That becomes y plus 3 equals 0, so y equals negative 3. The horizontal line is the more friendly one because it actually has a value for slope that you could actually use. If I said find the equation of the vertical line, well, now the slope is undefined. There's no way to plug that in. That's where you'd have to just know, oh, well, vertical, that's just the x equals, so that would just be x equals 4. All right, but now let's go back up here. We are graphing, we are solving these systems using the graphing technique. What does that mean? It means we are graphing each line. What is the solution? We're looking for the xy pair that satisfies both equations, not both over here. When we're solving this one, satisfies both of these equations, and then when we're over here, satisfies both of these equations. So I need both an x and a y. How am I going to find that? The idea of the graphing technique is their point of intersection is that solution. So this is a really, really nice section that if you understood the graphing, this goes very well. But if you struggle with graphing, this can become a nightmare. I've seen people try and go back and graph these using XY pairs, and it's a very long and uncomfortable process. So what should you be doing? Again, solve each for y. Get their m, get their b, and then we will use our graph paper to find that solution. So starting here, the 7x minus 2y equals negative 4, solving for y. I'll start by subtracting my 7x, canceling here, minus 2y comes down, not like terms, minus 7x minus 4, divide both sides by minus 2, don't lose that negative, that gives me a clean y. 7 and 2 don't reduce, but the negative over a negative is a positive. And then negative 4 over negative 2 is positive 2. As we said when we did the original video, I normally do the graphing at the same time, but for some people, they want to at least make their note. They know their m is the 7 over 2, and some even take it further. Rise plus 7, run positive 2, something like that. And then my y-intercept is 0, 2. Now the next one, 3x plus 5y equals 10. Same idea, minus 3x on both sides, trying to get to y. 5y equals minus 3x plus 10. Dividing both sides by 5. Doesn't reduce, stays negative 3/5 x. Don't lose your negative. Back here, a negative over a negative became a positive. Here, a negative over a positive is still negative. And then 10 over 5 plus 2. Slope, negative 3/5. Y-intercept, 0, 2. Take that information, come to my graph. My first one, slope is 7/2, y-intercept 0, 2, up 2 units, 7 over 2. 1, 2, 3, 4, 5, 6, 7 up, 2 to the right. I could keep going. I'm going to go off my grid, so I'm going to reverse it this time. What's the other way to look at a positive 7 over 2? I can make them both negative. Down 7. 1, 2, 3, 4, 5, 6, 7. left 2. So again, sometimes it's funny, we don't really have the best space to keep going in that natural direction, so to go the other way, and there is my line. There's my first line. And then my second one, my slope, -3/5, y-intercept 0, 2. Go to 0, 2. Down 3, 1, 2, 3, 4, 5 to the right. Down 1, 2, 3, 1, 2, 3, 4, 5 to the right. I had enough room to keep going. I could have reversed it. I could have went up 3, 1, 2, 3, left 1, 2, 3, 4, 5. That would have been another way. We see all these points lining up. Gives us good confidence. We did a nice job getting the points. And now this is kind of a little bit of a funny example. Now that we're done, and some of you probably saw it a few minutes ago, the point of intersection. Some of you, as we were doing this, kind of realized, wait a second, they've got the same y-intercept. No surprise, that's where they intersect. We've done other examples, intersects up here, intersects over here. We find that point of intersection. So to realize there's nothing that says the point of intersection can't happen on either the y or x axis. So just make sure we put it together. That's not 2, 0. My answer is 0, 2. I could easily confirm that, everybody. I could see it satisfies both equations. 0 for x, 2 for y. 7 times 0 is 0. Minus 2 times 2 is -4. 0 minus 4 is -4. Same here. 3 times 0 is 0. 5 times 2 is 10. 0 plus 10 does give me 10. No doubt that all that came together correctly, and that is the correct solution. And the next one, same idea. Let's take that same approach. Solving both for y, starting with this one, minus 4x plus 6y equals 18. Adding 4x on both sides, cancels here. A positive 6y comes down. 4x plus 18 on the other side. Divide both sides by 6. Here, 4 over 6 is okay, but so much better to see that that reduces and you get 2 over 3. So 2 over 3x, 18 over 6 gives me 3. Now the next one. Again, folks, this is just a little thing. Some people, they solve that. They got to write down their information. Other people can just see it. It's in the right form, so when they need the slope, they look here. They need the y-intercept, they look here. It's not about writing it out. It's about knowing what you need, so that way you could move forward. But now I've got to do it for this one. 2x minus 3y equals 3. Subtract the 2x from both sides. Cancels. Minus 3y comes down. On this side, minus 2x plus 3. Divide both sides by -3. Here they cancel, gives me my clean y. -2 over -3 is positive 2/3. And then 3 over -3 gives me a -1. Now, some of you, just like the last one, may have noticed that that y-intercept was the same, so to kind of jump ahead. And some of you might already notice something a little fancy is happening here, but let's pretend you don't see it. Let's come to my graph, and let's take this information. Up here, y-intercept 1, 2, 3 up. Slope 2 over 3, that's up 2 units, run right 3. Up 2 units, right 3. There's my line. And now let's do it for this one. My y-intercept is -1. Slope 2/3, up 2, right 3. 1, 2, 1, 2, 3. Up 2, 1, 2, 3 to the right. I see that line. And this is where just some people, how to write their answer. What's happening here, these lines are parallel. They don't touch each other, but that's where we get into issues. Some people come back and what's their answer? They write parallel. Well, that's true, but that's not the solution to the system. This solution would be that there is no solution. That's the way to make sure we answer it. And that's where some of you, again, you noticed that information earlier when we saw we had the same slope, we could already realize we are in the special case. That if we're thinking about the graphing technique, what's the three things that could happen with two lines? Most of the time, they're going to have that point of intersection, but they can definitely be parallel, and that's what we're seeing here. Never touch, so no solution. And the last is that they're really the same line. So here, they had the same slope, but by having a different y-intercept, that's how I knew they were not the same line. And some people could have avoided this. They didn't actually have to go through the sketch. You're still using the graphing technique because you're thinking about the graph, but once you make that connection, same slope, different y-intercept, those are parallel lines, so no solution. If I had the same y-intercept, then that would lead to the infinite solution.